Hello and welcome to this lesson. In this lesson, we'll be talking about how you can send Ether from your smart contract. So there are three distinct ways of sending Ether from your smart contract. There is the transfer function, there is the send function, and it's possible to use the low-level call function. So using the transfer function send Ether from your smart contract using 2300 gas stipend, and it reverts on failure. So if you try to transfer and you failed, it reverts and bubble ups, reverts all changes, and this is the most suitable function to use when you are transferring Ether, especially when in most cases it's the most suitable option. And the reason is because it depends on 2300 gas stipend. It is hard for an hacker to try to use or do any significant thing using the level of that gas fee. And whenever it fails, it bubbles up and reverts all changes. The second way, which is not advisable to use, is using the send method. Actually, using the send method has caused a lot of havoc to different smart contracts. By the end of this lesson, we'll be exploring one of those that have had that problem. Now, using the send method, set given amount of width to address returns false on failure. It doesn't revert, it returns false. So you'll have to handle the revert yourself. See, and forwards 2300 gas stipend not adjustable. Same thing as transfer, except that transfer reverts, which is good, and undo all changes to state, but send just returns false. Now the last one is when you use the low-level call function, which is the annotation of address to call byte memory. That's when you're trying to pass some data. It also returns false, right? Except that this is usually suitable when you exactly know what you are doing, and when in a case where you need more than 2300 gas. It means when you send, usually this happens when you are sending Ether to another smart contract, and the smart contract will be needing to not just receive Ether, especially when I'm calling your function, it needs to manipulate the state, so it needs to do a lot of other things. So you can forward all available gas to it, so it will be able to do all those things. But in most cases, you just want to transfer Ether, and transfer function is very suitable for most of these cases. So let's look at an example. We have this contract, Ether receiver, that has a fallback, that has a function which is payable, and this is a fallback function. And this is the old way of writing a fallback function. We should use receive, and it's going to be external. Yes, this is the correct way of writing it now. Receive, and it's going to be external. And we have Ether sender. This is just like a sink. It means every Ether that you send to it, it goes into it, and there is no way of getting it back. So we have Ether sender. So we have the type Ether receiver, which refers to this contract, private receiver address, new Ether receiver. Because it's in the same file, we don't need to, except it's being deployed, we don't need to pass the address of, but in a real life case, you want to pass the address of this contract to it. Then this function does send Ether, and then we have the amounts. Public payable means this send Ether can receive Ether. Then if address, receiver address dot send, if it's not addressed or it's not address send, now this returns false, and we have to undo the failed send here. And call value Ether, this is going to use the low level call function. So this way do require address, receiver address. No, this is wrong. In this case, we don't use require here. This is the case for require. This bubbles up itself. In this case, let's say bool sources then this is supposed to be which we can omit. It's supposed to be bytes, data of bytes that's been returned. So address receiver.call.value.gas. We can pass the amount of gas to it. That is one of the advantage that using the low-level call excerpt with. We can pass the gas. We can adjust the gas that wants to pass to it, and then check if sources. Then we perform our sources, else it fails, and then we handle it there. And for address.transfer, if this fails automatically by itself, it bubbles up. So point of note, both methods, transfer and send, are considered safe against reentrancy because they only forward 2300 gas. Transfer should be the go-to method to transfer Ether in most cases. Now, what do you understand by reentrancy? Reentrancy is when you call this function and before it's being executed, usually when we're performing something like this, sending gas, we'll probably be reducing, we'll probably be performing some state changes down here to reduce the amount of Ether, say, that the user is holding the smart contract. So the user can, because we are using this, can call the call value Ether using a small gas fee, which is going to slow down the transaction. And again, before this is being executed, and then we can update the smart contract to say, oh, this person has withdrawn the amount of this Ether from the smart contract. They'll keep calling it again. They'll keep calling it again. And by the time we are done, it's possible that the person is able to call the contract twice or more than that. That is why, while using this call function, which is a low-level function, it would be a good thing to use a function modifier to restrict reentrancy. So we can do that by doing so. We have our function modifier sending Ether, which we'll have here, this modifier, and then from sending Ether, we can have it and append this to it. We have table. What's the name of our modifier again? No reentrancy. So what this does is, whenever this call value Ether is being called, it's going to lock the smart contract. We're going to set full locked, which is going to be defined as false by default. So anytime this is being called, it's going to lock this function from being called, and it's going to slot. Remember, when we talk about modifier, it's going to slot this function body inside of here. When it locks is true, when it's done, it releases the lock, and then it can be called again. So it's going to help us guard against reentrancy. In a real life situation, in a smart contract that wants to deploy to the mainnet, this is going to be a little more complicated than this. I hope you've been able to understand how you can safeguard against no reentrancy when you're using the call low-level function if the case is required. So as we're saying, this is because, as we're saying, both method, transfer and send, are considered safe against reentrancy because they only forward 2300 gas. Transfer should be the go-to method to transfer Ether in most cases. This is because it reverts automatically in case of any errors. The send method can be seen as a low-level counterpart of transfer because it returns false. It should be used in cases where it's important that the error is handled in the contract without reverting all state changes. The low-level call.value method should only be used as a last resort as it breaks the type safety of Solidity, as I've mentioned. One of its application field is sending Ether to a fallback function that requires more than a stipend of gas. With its adjustable parameter, it can provide great flexibility for honest and experienced users, but also for malicious ones too. On one hand, the differentiation between the three methods used for the same task provides for flexibility, because the simple transfer function can be used for most use cases, while a more complicated call.value can be adjusted and used for specialized tasks. On the other hand, the differentiation can be confusing for developers and users alike, as there are no real semantic clues between the naming of different options as to where their difference could be. So a study case is the postmortem of King of Ether. Let's take a look at it briefly. So during the turbulent age, which is this state of the King of Ether throne, a serious issue caused some monarch compensation payments under and overpayments refunds to fail to be sent. So let's see, too long don't read. Sending Ether from one contract to another, such as the form of King of Ether contract, is to an Ethereum mixed contract-based wallet. So there are two types of wallets. There is the two types of addresses. There is the contract address, and then there is the EOA address, right? Which is the external, like an external wallet address. It's quite likely to fail if implemented in the obvious way. In Solidity kernel language, to insufficient gas. So the problem that happened that allowed the King of Ether, that caused the death of King of Ether, was because they used either of the transfer and send, which only is limited to 2300 gas stipend. And there were some addresses that were contract address that were calling the function. And so because the 2300 gas wasn't enough, it caused a problem. So if you want to see how this works, if you want to understand it well, you could visit the URL. It's going to be part of the code that's going to push on GitHub. And then you could just visit kingofether.com/postmortem to see what the problem is. I hope you're able to understand how you can send Ether from a smart contract and differentiate between using send, transfer, and the low-level call. See you in the next lesson.